Greetings everyone, today we are in second chapter basic mathematics. This will be the last lecture of this series. Second chapter basic mathematics, lecture number 11th. So in this lecture, students, we will discuss basically graphs and percentage change. That what is percentage change and what are graphs. The straight line and parabolas graph I have discussed. So in this lecture we will discuss only circle, hyperbola, ellipse and exponential graph. First, ellipse. Ellipse this is an ellipse. This is B axis, B semi-minor axis. A is what? Semi-major axis. Equation of ellipse x square y square upon b square 1. Right, students? So A happens to be semi-major axis. Semi-major axis. And B is what, students? Semi-minor axis. B semi-minor axis. Right, students? So the next figure is what, students? This is y axis. This is x axis. Next part to be discussed is circle. What circle is? So we all know circle figure. Let's see the representation equation. This is the representation equation. X square plus y square is equal to what, students? A square. Here A is what, students? Yes, the radius. Very good. So this is this. Now hyperbola. In this lecture, I will discuss only representation equations, not the general equation of circle, of ellipse and everything. Just the representation equation. Hyperbola. Hyperbola happens to form in two ways. One especially into the first coordinate. Yes, very good. And if it happens to form into the first coordinate, the second place it will form. Yes, it will form on the second and fourth. Very good. So this is hyperbola. This happens to form here. Okay. This is first coordinate, this is second, this is third, this is fourth. This is second figure of ours and this is first figure. Okay. So what the first figure means? X is such that 1 by y, then xy happens to be what, is it? Constant. This is first figure, meaning xy happens to be constant, first figure. Then second figure meaning, so it would be just opposite. Yes, very good. Oh, my speed. Y happens to be what, students? Y minus 1 by x, then this is what is, students? Xy minus constant. Right, students? The next part, exponential growth graph. What is exponential growth graph, students? Sir, in which there is exponential growth of something? Yes, very good. This is the answer. Okay, so when you have exponential growth, you have this graph. Exponential growth. Exponential growth graph. Growth graph. Growth graph. Now notice this is exponential growth that is happening on y-axis of any quantity, and it is x-axis. Generally it happens to be t. So the equation of the graph becomes what, students? So we don't know. So it becomes y a 1 minus e k x. Right, students? So I would write. So where would you write? There is no place to write. So this actually becomes we will also see numericals of it. The numericals of these graphs. Notice that value of y increases exponentially from 0 to a, then what should I write? Y approaches a as x approaches infinity. Right, students? Next, exponential decay graph. So let me explain for you that at zero value of x, a is, function is taking a value, and at infinity it takes to be, of course, at a value, at infinity value, the function becomes what? A value, and at infinity, at 0, it becomes 0. Okay, because 0 function is what? 1 minus 1. 1 minus 1, and this happens to be 0. Yes, what you are saying is perfectly right. Next, exponential decay graph. Oh sir, decay graph. So the graph of exponential decay would be just the opposite of it, right? Of exponential growth. So let's see what the graph looks like. This is the graph of exponential growth. of exponential decay. So this happens to be, yes, this is exponential decay graph, and its function is y a e minus kx. Now I would write again. Notice that value of y decreases, value of y decreases exponentially, then what should I write? So whatever it would be just the inverse of exponential growth. Yes, very nice. Y 0 as x approaches infinity. Okay, so notice when x is approaching infinite value, this whole value is becoming 0. Right, students? So this value, when you put x here to be infinite, this value becomes 0. Right now? So I should write y e k infinity, and this value is what? Infinite, and a upon infinite happens to be 0. So the next part, what it is? Questions. Numericals would come now. Find graph of following. Find graphs of following. First it happens to be y 4 by x. Second is y minus 2 by x. Third happens to be x square plus y square 16, and last is what, students? So ellipse. Very nice. Ellipse happens to be fourth one. This is x square plus y square, and this is 9, and this is 16, this is 1. Right, students? So this is the thing we got. Now solution. Let's see solution of this. First part happens to be this. This is first graph. Second, y happens to be 4 by x. Then second graph is this. This happens to be this. Right, students? So this is x, this is y. This is x, this is y. The next part, both are hyperbola. And second is also hyperbola. Now the third. What is the third, students? Third happens to be x square plus y square 16. Then this could be written x square y square 4 square. Right? So this happens to be 4. This is 4. This is minus 4, students. And this again happens to be minus 4. This is circle with radius 4. Circle with radius 4. Radius 4. Now the last ellipse, you think of yourself what could be the graph of it. While I am erasing. So this becomes x square 16 y square 9 1. This is an ellipse graph, and this is 3, this is 4, this is x, y, ellipse. Yes, what you are saying is right. Ellipse, circle, and here A is semi-major axis, semi-major axis, axis with value 4. B is what? Semi-minor axis, semi-minor axis, semi-minor axis, axis with value 3. Value 3. Yes, students, very nice. Now the next exponential graph. Exponential graph. So what the exponential graph? I will explain this to you with numerical. Velocity of a particle increases exponentially. With time t from 2 meter per second to 6 meter per second. 6 meter per second. Plot VT graph and write VT equation. Write Vt equation corresponding to it. Check equation with graph. With graph. Okay, students. So this is the question. Solution. Here, velocity of particle increases exponentially. So 2 meter is initial and 6 meter is final. So I will draw it. V meter per second, and this is time second, and this is 2 and this is 6. Alright, students, this is exponential growth that we are seeing. This is 2 value, this is 4. Alright, students, so equation becomes V is equal to 2 4 1 minus E kt. Okay, this is the equation. Here k is a positive constant. Which will depend on other factors. On factors not given in the question. Okay. So this becomes V2. Now put the values here. 4 E0, then this becomes 6. Students, right? The next, oh sir, what you are doing? This is 2. This is 1, no? Yes, 2 meter per second. And at infinite value, at infinity, at t happens to be infinity, V becomes 6. 2 4 1 minus E infinite E minus infinity, this becomes 6 meter per second. Yes, students. The next question. Question: acceleration of a particle decreases exponentially from 10 meter per second square to 6 meter per second square. Plot AT graph. Plot AT graph. Write AT equation. AT equation. Check equation with graph. With graph. So it is same question, students, right, with the previous one. Let's see the solution. You try to do yourself this question. How it can be done? First, try to draw the graph. So here the graph becomes what, students? 10. 10 to 6. 10, 6. This is 4 value, right, students? Yes, sir. Very nice. The next, this is what? Oh, sir is writing again x. T, sir. Second. And this is A meter per second square. Yes, very nice. Then the equation is A happens to be 6 and this is what, students? 4. 4 and this is again happens to be E minus KT. Yes, very nice. So at t equal to 0, A is what? Sir, 6 plus 4 E minus 0 and it is 0, then it happens to be 10 meter per second, right, which is the given value. And this is at t is equal to infinite. This is again what? 6 4 e minus infinite. This happens to be what? 6 meter per second. Okay. The next, percentage value, percentage change. Percentage change. Percentage change. What is percentage change? It is in x value and it happens to cause change in y value also. So this becomes final value. Final value. This is initial value minus 1. Okay, students, into 100. Okay. A point to be noted, if y value happens to relate to x such that y raised to power m and x raised to power n, then percentage change then percentage change in x is small, and percentage change in y percentage change in y is asked then we will not use this formula, student. Then final value upon initial value minus 1, we will use this. Then we can use approximation formula. Approximation result. This is m% change in y is equal to n% change in x. Okay, the next numerical on it. So one numerical will explain everything. One numerical. So question: relation between kinetic energy and momentum of a particle is what, students? Is P under root 2 mk. Find percentage change in P if first part K is increased, K is increased by 1%, second part K is decreased by 36%. Okay, but this is percentage we are given. Okay, so this is the thing. So I should write solution P is equal P under root k. Why sir, where did 2m go? 2m is constant or m is constant. Of course 2 is always constant and m is always constant. But here the quantity I will write. So P k 1 by 2, hence what the answer becomes, students? Percentage change in P equal to half percentage change in K. Right, students? So how did you get half? Think of yourself now. How did I got half? I use the second property, students. M percentage change, N percentage change. Here P is 1, this is half. Then this gives what? Yes, half. Oh sir, this is plus and this is 1. Yes, 0.5%. Very nice. Positive, because it shows it is increasing. Next, I would write, therefore P will increase by 0.5%. Yes, what you are saying is right. No need to write plus. B part, K is decrease. Okay, what is happening? Decrease is happening. K is decreased by 36%. By 36%. New value of K. New value of K. What it would be, students? K 64% of K. K dash would be 64% of K. Now you calculate what is 64% of K. Think of yourself now what it could be. It is K 0.64 K. Then K dash becomes 2 K dash, no sorry, P. Yes, what you are saying is right. P dash P 2 0.64 K M. And this is what is 0.82 km. So percentage change. So percentage change in P is what, students? Now we will use final value upon initial value minus 1 formula. So this becomes final value, initial value, minus 1 into 100. Put the values here, student. What are the values? 0.82 km under root 2 km minus 1 into 100. This happens to give minus 20%. So decrease is happening. Decrease in P. Decrease in P. Now the last part, componendo dividendo. The last part of basic mathematics, componendo dividendo. Componendo and dividendo. What it says, if A upon B, not A, P upon Q upon A upon B, then P plus Q, P minus Q, A plus B, A minus B. Okay, students. So this was componendo dividendo for us. This chapter ends here. Thank you.